Yo, wake up wake up it's go time. Digital Maths Academy in the house.
Hello intellectuals, I am Mr. Thakur and you are watching this video in Digital Maths Academy.
You want power, you want skills.
How much hours you study, that doesn't matter. How many subject matters you can memorize, that matters. In the previous video, I have already explained everything about the relations. That's from the root of the relations. What do you mean by the relations? Everything. If you haven't watched the video, the link is given in the description box. Kindly not to forget to watch the video. Today's topic is types of relations. There are so many types of relations. I'm going to explain some types of relations which are in classes 8 and 9. The first one is one-to-one relation. So I'm just going to explain it by drawing a mapping diagram. So let's say you have A and here is B. Here is 1, 2, 3. Here is A, B, C. A is mapped to 1 is mapped to A, 2 is mapped to B, and 3 is mapped to C. That's relation. So this is called one-to-one relation, right? So we can see each element of the set A has one image in the set B. Image is not repeated. A is the image of 1, B is the image of 2, C is the image of 3, okay? So images are not repeated. So in this case, such type of relations are called one-to-one relation. Just one more example. Let you have here A and here is B. That's the set of the domain and the set of the range. So here we have 5, A. Here we can see image of 1 is A, that of B is B, image of 3 is C, that of 4 is D, and 5 doesn't have any image in the set A, right? Even we can say it's one-to-one relation, right? And what's the difference between these two types of relation? Very soon I'm going to explain it in the chapter of function. So keep watching. Next type is the second part of the relation is one-to-many relation. One-to-many relation, right? So let's understand it by an example. We have A and B, that is the set of the domain and that the set of the codomain. So here we right. So here let one is mapped to A and one is mapped to B as well, right? 2 is mapped to C and that of 3 is to D. So such type of relation is called one-to-many. So we can see that here that's one element of the set A is mapped to more than one elements of the set B. So it is a one-to-many, right? Let's have another example here also. Let me have here A and that's a B. So A is mapped to 1, A is mapped to 2, and A is mapped to 3. So it's a relation. So we can say that one-to-many, right? So how to define it? If one element of the set A is mapped to two or more than two elements of the set B, then such type of relations are called one-to-many relation. As we can see that one-to-many, so we can see one-to-many. Next part of the relation is many-to-one relation. Many-to-one relation, right? Let's understand it by an example. Let's say we have here A and here is B. We can write here A, B, and C, and here is 1, 2. Now here 1 is mapped to, A is mapped to 1, B is also mapped to 1, and C is mapped to 2. So we can see here, A and B, that is two elements of the set A, are mapped to single element of the set B, right? So many to one. So such type of relations are called many to one. Let's have another example as well. Let me have here 1, A and B. So here we have 1, 2, 3. So 1 is mapped to A, 2 is also mapped to A, and 3 is also mapped to A. So such type of relation is called many-to-one relation. How to define it? So if two or more than two elements of the set A are mapped to single element of the set B, then such type of relations are called many-to-one relation. Inversal relation, right? Inversal. So first of all, to understand the inversal relation, first of all, we have a set A, 1, 2, 3. So of course we can find A cross A. Yes, you can see the ordered pairs of the Cartesian product A cross A, right? So you can see that. So in the inversal set, inversal relation, if we select all the ordered pairs of the Cartesian product A cross A, then such type of relation is called universal relation. Okay, so you can see all the order pairs are selected here from A cross A, right? So it's the relation from the set A to A, not to forget that. Inversal relation indicates from A to A, alright? So we can write here, that will be more clear. So it's the relation from A to A. That's first we get A cross A, alright? And then we have to select all the order pairs from the Cartesian product A cross A, and then all the order pairs represent the inversal relation. The next part of the relation is reflexive relation, right? I think you know the meaning of reflexive relation, right? When you stand in front of a mirror, of course you can see yourself inside the mirror. Reflexive. So from the inversal relation, if we select the order pair such that both the components are equal, then such type of relation is called reflexive. For example, here we can see here 1, 1, 2, 2, and 3, 3, right? So if we select them like this, here r equals to 1, 1, 2, 2, 3, 3, right? Then it's a reflexive relation. So but we cannot select here 4, 4. Can we select 5, 5, 6, 6? No, we cannot, because 4, 4, 5, 5, they do not belong to the inversal relation, right? So we can see in the Cartesian product there is no 4, 4, right? So the order pairs must be in the inversal relation. So we can only say it's a reflexive relation, otherwise not. But if we select only two order pairs, likewise 1, 1 and 2, 2, that is also reflexive relation, right? If we select only one, why only one? Yes, at least we have to select two. But if we select only one, doesn't matter. But only one, that's a point. So at least two order pairs are compulsory. So if we select two order pairs from the inversal relation such that both the components are equal, then such type of relations are called reflexive relation. Moving forward, let's have a look here. That's identity relation. Identity. As reflexive relation, in identity relation also we have to select the same order pairs in which both the components are equal. Yes, so we can see here there's 1, 1, 2, 2, and 3, 3, right? So it is, we can write here r equals to 1, 1, 2, 2, that's 3, 3. That is identity relation, right? But you can ask one question, so what's the difference between the reflexive and identity, right? So not to forget, in reflexive, I was telling you that in the reflexive, we can leave or we can reject one order pair. 1, 1, 2, 2 is also reflexive, but in the identity relation, we have to select all the order pairs in which both the components are equal, right? So in this relation, we can select 3 order pairs, and you can see in all the order pairs, both the components are equal. Transitive relation. Transitive relation, okay? In this relation, we have to use our mind. How? See carefully. Let we have here r equals to 1, 2, right? And here is 2, 3, right? See carefully. 1 to 2, 2 to 3, we wrote. Then 1 to 3 is compulsory, right? Not to forget that. I'm going to again explain it in short. Let we have a relation here from A to B, right? And another relation we have here, relation B to C. Then the relation from A to C is the transitive relation, okay? But we are not going to reverse, not to forget that. We are not going to write 2, 1. We are not going to write 3, 2. Just only from the left hand side to the right hand side, right? So another example, yes, I'm going to give you here. That is, if you write here A, B, that is B, C. See, A to B, B to C. Then A to C is compulsory to have transitive relation, right? So I'm very assured that you are understanding. So what do we mean by the transitive relation? That is A to B, B to C. That should be from A to C as well. And if you have more than 3 elements, we have 3 elements in the any set, then similarly that you can make. But never ever forget that that should not be B, A. That should not be reversed. Right? So if you have any question regarding this, you can write the question, you can write your confusion in the comment box. Of course, I will reply. The next part is symmetric relation. So what do you mean by the symmetric? Have you seen x-axis and y-axis? Y-axis divides both the portion in equal shape, right? In equal part. It means both the sides are equal, exactly equal. That is symmetric line, right? So in the symmetric relation, first of all, what you have to understand is that if you have, okay, anything that you have here, a comma b, here you have b comma a, then you can c comma c. That is symmetric relation. How to know? Just I'm going to explain it, okay? At the a side and at the b side. A side means that's x component and the y component, okay? See here, one, only one time, right? B, only one time. C, one time. A is one time, B is also one time, C is also one time, right? That is symmetric. Symmetric means what now? The number of the x components should be equal to the number of y components. Let's understand it by another example. Here is 1 comma 2. Do you think it's a symmetric relation? No. See carefully here. I'm just going to prove it. 1 is at the left hand side, 1 is not at the right hand side. Correct? 2, listen, 3 is also at the left hand side. 3 and 2 is also at the left hand side, right? But at the right hand side, you can see we have 2, we have 4, double at the right hand side, correct? Isn't it? So the number of the x components at the left hand side and that at the right hand side are not equal, isn't it? So it's not symmetric. So how to make it symmetric? How to make it symmetric? Okay, so we have to make symmetry. We have to add 2 times 4 at the left hand side and 1 we have to add at the right hand side. Okay, and similarly 3 we have to add at the right hand side. Okay, so we can write here 4 comma 1, right? So 4 is added here, 1 is added here, right? So now 1 4 is still remaining. Then we can write here 4 comma 3. Now just see carefully here. 1 we can see at the left hand side, correct? And 1 is at the right hand side. We can see that. 3 we can see here 3 is at the left hand side, but 3 still is not at the right hand side. Right hand side also we have 3 here. See that here 3. Here is right hand side. Okay, so number of x components at the left hand side are equal to the number of y components at the right hand side. So such type of relations are called symmetric relations. Okay, so just you can check it, okay, whether it's a symmetric or not. There should be equal number of x components and the y components. Okay, then only you can see symmetric, otherwise not. Okay, moving forward. So hope you may have understood the parts of the relation. So in the next video, I'm going to explain function from the root, from the basic, right? So not to forget to watch the next video. And if you have liked this video, then not to forget to like and share to your friends. And if you are new, then not to forget to subscribe my channel because it's your channel. And not to forget to hit the bell icon so that you can get the update of my videos regularly and you won't miss my videos. Thank you. Have a nice time. Have a good day.
Digital Maths Academy in the house. SK Sir on the lead. Let's ride. Tick, tick, boom.